Okay, so now we'll go through question 9 of the 2024 O-Level A-Math paper 2. So for part A, it's on proving an identity. And for this question, you basically just have to try to identify what are the similarities between the left-hand side and right-hand side. Okay, so that you know, it can give you some clues on what you're supposed to change to get the other side of the equation. Okay, so for example, for question 9, we always start with the more complicated side. So in this case, I'll start with the left-hand side so that I have more to change about the expression. Okay, so I'll start with the left-hand side. So from the left-hand side, tangent x plus cotangent x equals to sine x over cosine x. So this is what you can change tangent x to. And then plus cotangent is just the reciprocal of tangent. So it will be cosine x over sine x. Okay. Then after that, I'm going to combine them into one single fraction. So I need a common denominator, right? So this will be sine square x for the numerator plus cosine square x for the numerator of the other fraction. And then the denominator will be sine x cosine x. Okay. And we know that there's the identity that tells us that sine square x plus cosine square x is equal to 1. So the numerator here will just be 1. And the denominator remains as it is. Okay, and also remember that there's an identity 2 sine x cosine x. Okay, it will be equal to sine 2x. Okay, we'll use that in the next step, but for now, I just want to change the sine x cosine x into 2 sine x cosine x. But I can't just add the 2, right? I have to make sure that it's still the same as the previous line. So because I added that factor of 2, I must also add this extra factor of half. Okay, so that I don't change the expression that I have. Okay, so 2 sine x cosine x is equal to sine 2x. So this is basically 1 over half times sine 2x. And I'm going to multiply the numerator and denominator by 2 to get rid of the half in the denominator. So this is 2 over sine 2x. Okay, and 2 over sine 2x is basically 2 times 1 over sine 2x. And 1 over sine 2x is cosecant x. So this is 2 times cosecant x, which is the right-hand side. Sorry, this is cosecant 2x, not cosecant x. Okay, so that's how you solve part A. Okay, then next for part B, we're supposed to solve this equation. So from part A, we already knew what that left-hand side was equivalent to. So we're going to use our part A solution. So from part A, okay, we're going to substitute the 2 cosecant 2x into the left-hand side. So it'll be equal to 3. And cosecant 2x will be equal to 3 over 2. And cosecant 2x is just 1 over sine 2x. Okay, and so sine 2x is just the reciprocal. Okay, so basic angle of 2x. Okay, will be sine inverse 2 over 3. And in radians, that will be 0.72973 to 5 SF. And we know that the range they gave us was 0 to 2 pi, right? Okay, so because now our angle that we are handling is 2x. Here, recall, this is 2x. So we must change our range as well to 2x, which means this will be between 0 and 4 pi. Okay, so we know that 2x will be equal to different values depending on the ASTC diagram. So recall your ASTC diagram. Okay, ASTC. So we have the sine, we have a sine function here, right? So, and it's equal to positive 2/3. So we are only focusing on the first and second quadrant. Okay, and our range is 0 to 4 pi. So that will be 2 rounds around the ASTC diagram. So our angles will be in the first and second quadrant, but for 2 rounds. So 2x will be 0.72973. Okay, that's the first angle in the first quadrant. For the second quadrant, it will be pi minus 0.72973. And then we go for the next round, when we come back to the first quadrant, that will be 2 pi plus 0.72973. And the last angle will be 2 pi plus pi. Okay, so 3 pi minus 0.72973. That will be in the second quadrant, but for the second round. Okay, and then we simplify our answers and divide by 2 because we only want x. That will be 0.365, 1.21, 3.51, and 4.35 to 3 SF because it's your final answer in radians. So for this question, you have to answer in radians because they gave you the range in radians as well. So you just follow the same units for the angle. Okay, the last part, use the result in part A to find the set of values of the constant k for which there are no solutions to the equation tangent x plus cotangent x equals to k. Okay, so now the left-hand side remains the same, right? And recall the right-hand side in the equation was, what was it? It was 2 over sine 2x. Okay, or you can start with 2 cosecant 2x. It's still the same thing. Okay, so basically here we know that k is equal to 2 over cosecant 2x. So since we know this, and we also know just from general knowledge, we know that the sine function can only be valid between this range. Okay, so sine 2x must be between -1 and 1. It cannot be less than -1 or greater than 1. Okay, so this is the range of values for which we will have a solution. Okay, so what about 1 over sine 2x? So if you want the reciprocal, so we want to know what 1 over sine 2x can be, like what range it can be. So when you get the reciprocal, you can just get the reciprocal of the lower and upper boundary too. So like the reciprocal of -1 is actually still -1, okay, because it's 1 over -1. So it's still -1, but we flip the sign. Or sine 2x, okay, the reciprocal of 1 is still 1 because it's 1 over 1. But again, we have to flip the sign. Okay, so basically, 1 over sine 2x can only be less than or equal to -1 or greater than or equal to 1. Okay, this will be two separate inequalities. Okay, okay, so sorry, this will be 1 over. Yeah, because we already got the reciprocal. Okay, so now we know this is the range for which it will be valid, okay, for which there will be solutions. Okay, recall? So, but now we want to know k, right? Like for which range of values will k have solutions? And k is not 1 over sine 2x, but it's 2 over sine 2x. So now let's do that small change. So 2 over sine 2x. Okay, we just have to multiply this by 2. Okay, so it will be less than or equal to -2. Or, again, this one also we multiply by 2. It will be greater than or equal to 2. Okay, so this, remember, for which these are the ranges for which there are solutions. Okay, but the question wants to know for what range there won't be any solutions. So let me just make it clearer for you by drawing out on a number line what this looks like, okay? Why did I write them as two separate inequalities, you might be wondering? Because at this stage, it was one combined inequality, right? But the thing is now I cannot combine them into one connected range anymore, and this is why. Okay, so let's represent this on a number line. So let's say this is -2, this is positive 2. If 2 over sine 2x is less than or equal to -2, it will be like this, because it's less than or equal to, right? It will be in this direction. If it's greater than or equal to 2, which is this part of the inequality, okay, it will be like this. So you see, these are two separate inequalities. They are not connected together. So that's why I couldn't write them as one single connected inequality. Okay, yeah, but this is the range of values for which there are solutions. But for no solutions, you can see that it's basically everything else, right? You can see that between this entire range, this connected range, there are no solutions. Okay, so we can conclude that for no solutions, k must be bigger than -2 and smaller than 2. So that is your answer for part C.